Here's question 120. I think these are probably some of your harder questions. So let's know the pH of 3 different solutions. Notice one of them is potassium nitrite, sodium hypochlorite, and ammonium perchlorate. Well, none of these have a hydrogen in them. None of them are derivatives of ammonia, of NH3, but they still might be acids or bases. So this would dissociate into potassium ions and NO2 negative ions. Potassium ions do not affect pH. NO2 negative cannot be an acid, it is a base. So plus HOH, it takes a hydrogen from that, makes HNO2. So H negative, so that's the first thing you have to know. I want to know the pH, so in order to know the pH, we have to know this initial concentration, which is 0.12 molar, and we need to know the Kb value of NO2 negative, which if you have that on a chart, would be good. You might know the Ka of this, it's conjugate acid. The Ka of this is 4 times 10 to the negative fourth. Remember, Ka times Kb for conjugate acid bases equals 1 times negative 14. So if I take 1 times negative 14 divided by that, I get this Kb value, which is 2.5 times 10 to the negative 11th. Any weak acid or base, if I take its Kb value, equals x squared over the initial concentration. So the Kb value out here, 2.5 times 10 to the negative 11th. So cross multiply square root, get your x. And x is going to be our concentration of OH negative in this case because it is a Kb value. It'll also be the concentration of your weak acid, but it is 1.7 times 10 to the negative 6 molar. POH would be negative log of that value. POH would be 5.77. 14 minus that would be your pH. pH is 8.23. So a 0.12 molar solution of this, of that salt, is a weak base. I'm not going to do the next one, but you got to figure out the sodium affect pH. It does not. OCl negative does. Just like this does, it is a weak base. I'll tell you the answer to this one is 10.56. I'll do the last one. Ammonium perchlorate. So it splits apart into NH4 plus ions and ClO4 negative ions. This does not affect pH, it always dissociates. This is a weak acid. You can put plus H2O if you want to for acids. Acids always give a hydrogen, they make H3O plus. Remember, that's the same thing as H plus. H3O plus, hydronium ion, same thing as H plus. Plus the conjugate base NH3. I know that this Kb value is 1.8 times 10 to the negative fifth. So I can get this Ka value, and it is 5.6 times 10 to the negative 10th. And it's a 0.4 molar solution. So the Ka, 5.6 times 10 to the negative 10th equals these two concentrations at equilibrium, x squared over 0.4 minus x, but ignore the x. Cross multiply square root. X, since this is a Ka value in this case, is concentration of H plus or H3O plus. And in this case, it is 1.5 times 10 to the negative fifth molar. pH is the negative log of that. And the pH is 4.82.